Okay, let's determine if this matrix here is invertible. So to determine if this is invertible, we're just going to go ahead and try to find the inverse. So the process for doing this, we want to set ourselves up in what the textbook calls supersized matrix, right? So we're going to take this guy and put it in a matrix where we have here our numbers from that. And then we're going to put the 2 by 2 identity matrix here. So there's ones here and zeros here. So we're going to take this, and if it will work, we're going to transform this into something that looks like this. Whoops, 0. And then our inverse is going to be over here, right? So if I called that A, right, this is going to be my inverse over here. If I can do this, we're going to find that's my inverse. So let's take a look at what's going on. We want to transform this guy so that it's this, we called that reduced row echelon form before, right? So we're just going to do row operations on these, to try to make it work, right? So we want to put a 1 in this position, and we want a 0 here, and a 1 here. So it seems like the easy thing to do would be to use that 2 to get rid of my 4, because I know that 2 is a multiple of 4, so I can just take, maybe I'll do a different color here. I can do row 2 minus 2 times row 1 and put that in place of row 2. Okay, so if I do that, I'm not changing my first row at all. That's staying the same. So I'm going to just copy those down. And now here, I'm going to replace that row 2. I'm going to replace that with row 2 minus 2 times row 1. So I'm going to take row 2 minus 2 times that position. So 4 minus 2 times 2. So that's 4 minus 4. That's 0. Okay. And then I've got row 2. That's 2 minus 2 times row 1. That's also 0. So this is going to indicate to us that something's fishy, right? So we got all this stuff zeroed out. So now what? I've got, move over here. So I got row 2 minus 2 times that one. So I got negative 2. Row 2 minus 0 would be 1. So at this point right here, we're going to be able to tell immediately that we do not have an inverse here. Because we have zeros. There's no way I'm going to be able to get a 1 there without putting another number over here. So at this point, we say this is not invertible. Not invertible. Okay, now let's take a look at something that we would do in outside of this matrix situation. So if I had a system of equations that I was using this matrix to help me solve, I might have some coefficients out here. Who cares what they are? It doesn't really matter. So in finding my inverse, when practically speaking, what we're using this for is we're using this to solve systems, right? So if this thing does have an inverse, I'm going to be able to solve this system. But looking at the system back to when we did 8.1, this system is not going to have any solutions, and we can see that because they're parallel lines, right? If I wanted to rewrite that system, I can write this 2 times that. It would be, so I'm going to take 2 times row 1, put that in place of row 1. That's going to be 4x plus 2y equal 4. And then we have the bottom didn't change. So in a situation where we've seen this before, our matrix was not invertible, and that was because this doesn't have any solutions, right? No solutions. We're going to find that the invertibility of a matrix is independent of these constants. It doesn't really matter. So we're not exactly going to be able to, immediately say if we have a situation where there are no solutions or if there are infinitely many solutions. But in this section, all we care about is that it's not invertible. So when we try to find the inverse, we're going to find that we have zeros in one of the rows, and that's going to indicate to you that it does not have an inverse.